L'Hopital's rule is used to determine the limit of a function as x approaches c, and it's used when the limit as x approaches the c value is an indeterminate value, such as 0 over 0, infinity over infinity, negative infinity over infinity, positive infinity over negative infinity, or negative infinity over negative infinity. So L'Hopital's rule says, let f and g be functions that are differentiable on an open interval a to b containing c except possibly at c itself. Assume that the derivative of g of x does not equal 0 for all x in a to b except possibly at c itself. If the limit of f of x over g of x as x approaches c produces the indeterminate form 0 over 0, then the limit as x approaches c of f of x over g of x is equal to the limit as x approaches c of f prime of x over g prime of x, provided the limit on the right exists or is infinite. This result also applies if the limit of f of x over g of x as x approaches c produces any one of the indeterminate forms, and that's where the infinities, negative infinity over infinity, where these come in. So these and 0 over 0 are the only indeterminate forms that can have the L'Hopital's rule applied to them. So if any other indeterminate form is resulted, then you cannot use the L'Hopital's rule. So let's try a practice problem. Okay, and we have the limit as x approaches 0 of e to 2x minus 1 over x. Oh, and also for the indeterminate forms, what I use to help remember what forms can be used for L'Hopital's rule is 0 over 0 and anything with the infinities over another infinity. So if it's infinity over infinity, negative infinity over infinity, any of those where the numerator and the denominator both contain infinity, then you can use L'Hopital's rule. But if it has like a 0 anywhere, then you cannot use it. That's just like a little thing that I use to help remember. Okay, so back to the problem. The limit as x approaches 0 of e to the 2x minus 1 over x. So the first step that you need to do is you need to find what this limit is. So the limit as x approaches 0, and in this case you just substitute in the value that x is approaching into the x. So e to the 2 times 0 minus 1 over 0. So e is a numerical value. It's just like pi. It represents another number. So from here you get e to any number to the 0 power is 1. So you get 1 minus 1 over 0, and you get 0 over 0. Now 0 over 0 is an indeterminate form, and because it's 0 over 0, you can use L'Hopital's rule. So remember, L'Hopital's rule states that the limit as x approaches c of f of x over g of x is equal to the limit as x approaches c of f prime of x over g prime of x. So because of this, you can use the rule. So we need to find f prime and g prime. So f and g. F is equal to e to the 2x minus 1, and that's the numerator. So you can basically put this in this form. Okay, so now g is equal to x. The derivative of f is equal to, well, e is just a number, so that means that the, oh, my bad. So we have to, bring down this value, which is 2. So you get 2e the 2x, and then g prime, the derivative of a constant x is 1. Is that right? Yes. Yeah. Okay. So then you substitute these values into the L'Hopital's rule, the equation that you get. So the limit as x approaches 0 of f prime of x, which is 2e to the 2x over 1, is equal to 2e to the 2x. So then you have to substitute in 0, just like usual. So then you get 2, or my bad, this is limit as x approaches 0. You have to rewrite it. So then afterwards, you substitute in 0, 2e to the 2, 0. And now it's 2 times e to the 0. So that means e to the 0 is 1. So it's 2 times 1. And the answer is 2. So the limit as x approaches 0 of this function is equal to 2. So now let's try another one. Find the limit as x approaches 0 of the natural log of x over x. So, like last time, plug in your zeros. Or, this should be infinity. Okay, so the limit as x approaches infinity. So plug in infinity, and you get infinity over infinity. And this is another indeterminate form that you can use L'Hopital's rule for. So this is indeterminate. So f is equal to the natural log of x, g is equal to x. F prime is then equal to 1 over x, and g prime is equal to 1 because x is a constant. So now we are going to write the equation. So the limit as x approaches infinity of 1 over x over 1. So you write the equation, limit as x approaches infinity of 1 over x, which is the f prime, over g prime, which is 1. And then that gets you 1 over x. So what is the limit? What is the limit as x approaches infinity of 1 over x? That's 1 over infinity. So what happens to the number when the denominator increases in an unbounded direction to the right or to the left? You get 0. So therefore, the limit as x approaches infinity of the natural log of x over x is equal to 0. And also keep in mind that you can use L'Hopital's rule more than once if you get an indeterminate form that is applicable both times after using the equation f prime over g prime can be used to determine the limit as x approaches c. Now let's look really quick at some instances where there's an incorrect use of L'Hopital's rule. So in this case, the limit as x approaches 0 of e to the x over x cannot equal the limit as x approaches 0 of e to the x over 1. And you cannot conclude that it equals 1. Instead, you have to do e to the 0 over 0 is equal to 1 over 0, and that cannot be determined, or that does not exist. Because this is an indeterminate form, but it is not one of the infinity over infinities, or it's not a 0 over 0. So therefore, you cannot use L'Hopital's rule and conclude that, and use the f prime over g prime equation.